All right, welcome back. In this lesson, we're going to be talking about patterns and nonlinear functions. So if we remember, non as a prefix means not. So we're talking about not linear. So these are going to be any curve, anything that is not a straight line. So let's get moving. All right, so key concept, linear function is anything that creates a line that is non-vertical, meaning it can be horizontal, but it can't be a vertical line. And there's a reason for that. We'll talk about that when we talk about what makes something a function over not a function. A nonlinear function, if you look at these are our curves, or the last one there, this one right here, that is our absolute value graph. So we're working with things that are not straight lines that strictly increase by the same thing over and over again. So, all right. So example 1, classifying functions as linear or nonlinear. So we're given two tables. One is the table telling us the function between our pizza area and its radius, and the other one is the weight versus a weight of sauce versus the cost of the sauce. So as I graph these, and I'm going to graph them to show whether it's linear or nonlinear. And I'm going to move my window just a little bit so we can see a little bit more. So I'm going to graph my area first. So my y-axis is area, and my x-axis is radius. And we're going to count by twos, which I would write, but it's not allowing me to get that close. So we're counting by twos across the bottom, and we're going to count by 50s going up. So I'm going to count two boxes. Every two boxes is 100. So that's what I'm going to write here. All right, so now graphing it. We're starting at 0, 0. So I'm going to do my best to put a 0 at 0, 0. I'm actually going to graph. That way we don't waste time. And then I'll come back and we'll talk about where I place the points. All right, so I just finished graphing the first one. So if you need to pause it and copy these points, then do so. But we would be here forever if I was trying to do this on the video. So I have a point at 0, 0, because if we had a 0 radius, we'd have a 0 area. And then I kind of missed my point down here at 2, 12.57. And then here's where I placed my 4, 50.27, my 6, 113.10, my 8, 201.06, and my 10, 314.16. So that's how I came up with those points. They just came directly off the table. When I graph these, this is not a straight line, it is a curve. Therefore, the pizza area is that looks like a W instead of an N, non-linear. All right, and then we're now going to graph the sauce, the cost of the sauce versus the weight. And I'm going to do this by twos as well. So 2, 4, 6, 8. And then we're going to count by ones on my Y. So 2, 4, 6, 8, and then 10 all the way up here. And then just for the sake of it, I'm going to pause. So all of a sudden, you're going to just see my graph pop up. All right, so I've taken this table about the sauce and the cost, and I've now graphed those points, estimating to the best of my ability onto the graph. Now this one is, even though my line doesn't go through it, this is more linear than the other one. So we're going to say that this one is a linear function. And the other thing that would tell us that is like from 80 to 160 or $1.60 is 80 cents and 0.80. And from 160 to 240 is 0.80. And from 240 to 320 is 0.80. And from 320 to 4 is 0.80, which means we have that constant rate of change, which makes it linear, whereas this one does not have that constant rate of change. And so we just answered. Pizza area is nonlinear, and the sauce cost is linear. All right, example 2. Representing patterns and nonlinear functions. So the table shows the total number of blocks in each figure. Below is a function of the number of blocks on one edge. What is the pattern you can use to complete the table? Represent the relationship using words, an equation, and a graph. So I do know in the table that I can go ahead and fill in my x values on my points. So that's 4 and 5. Now, to figure this out, I know that to find volume, I am taking length times width times height. Now, in this case, length, width, and height are all the same. And so, like, when I find the volume of a cube with 1 cube in it, it's going to be 1 times 1 times 1. For 2, it's going to be 2 times 2 times 2. And for 3, it's going to be 3 times 3 times 3, because I have side of 3, side of 3, and side of 3. So that's where we're getting our values. And if I do it, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. So my pattern is that I'm going to do 4 times 4 times 4, which gives me 64. So I have 4 comma 64. And then I'm going to do 5 times 5 times 5, which is 125. So that gives me my table. If I'm going to write this as an equation, my equation is going to be that y equals, we are taking our number of cubes on the side of the box, or number of blocks in a cube, and I'm going to take that number and I'm going to cube it. I'm going to take it times itself 3 times. So that's our equation, y equals x cubed. And then if I write it in words, we're going to say the total number of blocks y is the cube of the number of blocks on one edge. Oops, that's an N, not an H, on one edge, and that is our X value. So that's using words, and then I've got to graph it. So I am counting by ones across, and so this would be 1, 2, etc. And I'm going to 1, 2, 3, 1, 2, 3, 1, 2, 3. All right, so we have 1, 1, which would be barely off. See, this is why I'm going to pause and graph it and come back. All right, so I've graphed it. We do not draw a line on this one because the line represents everything in between, whereas this is only for those sides of a cube. And so we're not working with 1.5 cubes. And so we are just going to have the dots, and that's where they will land. And so this is a nonlinear function because it doesn't make a line. And that's how that works. And we've shown it in an equation, words, table, and a graph. All right, last one. Oops. Maybe there are finally went. All right, so example 3, writing a rule to describe a nonlinear function. The first thing I would do on this is draw yourself a table. So we have x and y. So we have 1, 2, 2, 4, 3, 8, 4, 16, and 5, 32. Those are our values in our table. Now, what we're trying to do is write the equation. Rule just means equation that relates x to y. So I know that to get 1 to get to 2, there are multiple ways I could do this. I could say that y equals 2 times x, because that's 2 times 1, right, which equals 2. That could be that y equals x plus 1, because 1 plus 1 is 2. Or it could be that y equals 2 to the x power, because 2 to the first power equals 2. So here's how, these are 3 ways that I can get from x being 1 to y equaling 2. So now I need to just figure out which of these works for every single one. And so then I'm going to plug in 2. If I do 2 times 2, I get 4. So far that one works, right? These worked on each of these. If I do 2 plus 1, I get 3. That one does not work, so this one's not an option. If I do 2 squared, I'm now going to get 4. So far it's down to these 2. Now I'm going to do 2 times 3, because my x value is 3, and I get 6. That does not work. I'm trying to get 8, so that one is out. And if I do 2 cubed, 2 times 2 is 4, times 2 is 8. And then just to double check, if I do 2 to the 4th power, so 2 times 2 times 2 times 2, that gives me 16. And if I do 2 to the 5th power, that's 16 times 2, which is 32. And so this is my function, y equals 2 to the x power. The easiest way to write those equations, or if it's giving you multiple choice, is just to plug your x values in and make sure that you get the same y value as your table. If you don't get the same y value as your table on any of those values, then you need to, or on an equation, then that one's no longer an option, and you're looking at the other equations. So, all right, that is it for linear and nonlinear functions. So until next time, 8th graders.